Yeah, hello friends. Welcome back to Ekeeda. So in the present lecture,
Welcome back to Ekeeda. So,
let us solve some of the previous year gate questions on the laboratory test to determine the shear strength of a soil. So, if we brief into the laboratory test to determine the shear strength of the soil, like we'll have the direct shear test, triaxial shear test, and also we are having the unconfined compression strength, and also we are having the vein shear test. So that is useful in field, and also it will be used in the laboratory. Okay, let us start with some of the previous year gate questions. So let us read the question. The following are the statements related to the stress paths in a triaxial testing of soils. Okay. So if we see stress paths for a triaxial test, then these are the statements given. So first one is given that if sigma 1 equal to sigma 3, stress point lies at the origin of the PQ plot. That means first we should know what is the diagram that otherwise we should draw the stress paths variation. Suppose if I draw the representation, let us say that along the x-axis normally we will represent with P, and along the y-axis we will represent with Q. And if I draw some variation, let us say for the particular type of soil, and this is the variation. Now here P we will represent with P in general we will represent with sigma 1 plus sigma 3 by 2, and Q we will represent with sigma 1 minus sigma 3 by 2. So what is the first statement given? The first statement is nothing but if sigma 1 equal to sigma 3, the stress point lies at the origin of the PQ plot. That means if the stress paths joins from here, that means if the curve starts like this, then it is possible when they are saying that sigma 1 is equal to sigma 3. And what is the second one? If sigma 1 equal to sigma 3, the stress point lies on the p axis of the PQ plot. Suppose if sigma 1 equal to sigma 3, we can say that your Q magnitude is equal to 0. But what about the magnitude of P? We will have definitely some value P. So if we are having definitely some value P, definitely we can say that the Q is representing the y ordinate, P is representing the x ordinate. So in the second question, if sigma 1 equal to sigma 3, then what we are saying? Your Q, that is nothing but your y ordinate will be equal to 0. But definitely there will be some magnitude P that will be there along the x-axis. Then where the curve will start from somewhere like this. Okay. So this is what when sigma 1 equal to sigma 3 happens. So with this, let us come to the conclusions. What is the first statement? If sigma 1 equal to sigma 3, they are saying that the stress point lies at the origin. But is it exactly lies at the origin? If sigma 1 equal to sigma 3, no. It is starting from some shift along the x-axis. So we can say that our first statement is false. Then what about the second statement? If sigma 1 equal to sigma 3, the stress point lies on the p-axis of the PQ plot, isn't it? So if you have sigma 1 equal to sigma 3, it is by this curve we can show that our curve is lying on the x-axis. That means you can see it is lying on the p-axis. So we can from this, your first statement is wrong, your second statement is correct. And what is the third statement? If sigma 1 is greater than sigma 3, then it is saying that both the stress points P and Q are positive. So by seeing the variations, so what is the P value? Sigma 1 plus sigma 3 by 2. And whatever the Q, sigma 1 minus sigma 3 by 2. And if your sigma 1 is greater than sigma 3, then it is obvious that both the values are positive. So from this we can conclude that your P statement is false, Q statement is true, and R statement is true. So if we see all these options, then option E is matching with the all of these. So we can pick up A is the correct answer for this question. So here we should know that what is the value of Q, and also we should know what is the value of P. And if we know these two, then we can easily choose one of the answer. So here it is asked for the 2 marks. So only we should know that how the stress path varies with and we should know that what is the value of Q, and also we should know the what is the value of P simply, like sigma 1 minus sigma 3 by 2 or sigma 1 plus sigma 3 by 2. If you just remember these two, then obviously we can pick up the correct answer easily. So, but in exams normally where we'll do mistake is that we know the plot. We know stretch paths are nothing but a sigma 1 plus sigma 3 by 2 or sigma 1 minus sigma 3 by 2. But the point is where, that means whether it is P or sigma 1 minus sigma 3 by 2 or whether Q is sigma 1 minus sigma 3 by 2. So wherever there is a slight variation like plus or minus, we should concentrate it more, or indirectly we should tell to ourselves, okay, P, like it is positive or negative, Q it is positive or negative, so that we will not commit the mistakes in the exam. See, there is no much calculation needed for this problem, but if we simply remember this directly in our hand, we can score the 2 marks, right? So like that. And let us see next question. a consolidated undrained a consolidated undrained triaxial compression test. So in this question, it is related to the experiment, the triaxial test, is conducted on a normally consolidated clay. So here the experiment is conducted on a normally consolidated clay and at a confining pressure, and the V deviator stress at failure is 80 kilopascal. The pore water pressure measured at failure is 50 kilopascal. So what they're asking, the effective angle of internal friction, they're asking in degrees up to 1 decimal point. Okay, now let us represent this is a normally consolidated clay, and in which type, in an consolidated undrained test. Suppose, and also what is the given data? Confining pressure. Confining pressure is given as nothing but a confining pressure is normally representing with minor stress. So minor principal stress is given as how much? 100 kilopascal. And also what is the applied stress? Deviated stress. This is normally represented with sigma subscript D. And that is given as how much? 80 kilopascal. And also they are given as the pore water pressure. So pore water pressure in general we will represent with U, and that will be equal to 50 kilopascal. And what we have to find? We have to find the C, effective angle of friction. So while conducting the test, there are two parameters. Either it is in undrained condition or whether it is in the drained condition. That means either we are using the total stress parameters or we are using the effective stress parameters. So if we are using the effective stress parameters, then we have to use the effective parameters of the soil, that is nothing but effective cohesion, effective angle of internal friction. So here they are asking about the effective in angle of internal friction. That means they are asking the phi dash. So as we have to find out the phi dash effective, so stresses also we have to represent in a effective, we have to take the effective values, right? So first thing in our mind, we should understand that if we are conducting normally consolidated clay in a consolidated undrained test, then it will be observed that your undrained cohesion and your effective cohesions will be equal to 0. If we don't know that your either Cu or C dash is equal to 0, then in this problem we can't go forward. So before moving on to that, let us discuss the relationships between the principal stresses and the effective stress parameters. So what we can write it down? We can write it down as sigma 1 dash, that will be equal to sigma 3 into, so if I'm using effective stress parameter, sigma 3 dash into tan square of 45 plus 5 dash by 2 plus 2c dash of tan of 45 plus 5 dash by 2. So here in this equation, how many unknowns are there? So they have given sigma 3 and sigma d and also u. That means we can find out sigma 1 dash and also we can find out the sigma 3 dash. But what they are asking us to find the effective angle of internal friction. So if we want to find out this phi dash, then we should know this c dash also, isn't it? But if you don't know that in a normally consolidated clay, in consolidated undrained test, if you don't know that your c dash is equal to 0, then you will think that sufficient data is not given, and you will enter some answer and you will think that you will get some marks. But if it is a normally consolidated clay and if the experiment is conducted in CU test, then your C dash is equal to 0. Now the equation will be simplifying like it is nothing but a sigma 1 dash, that will be equal to sigma 3 dash into tan square of 45 plus 5 dash by 2. So from this equation, we have to find out what is the phi dash value. And remember, we have to substitute the values in degrees. And so what about the sigma 1 dash value? Sigma 1 dash, it is nothing but a, we can represent it deviator stress plus confining stress. So these two are in the effective stress parameters, but we have to use the effective stress. If you want to use the effective stress, then minus we have to subtract the pore water pressure. So what is the deviator stress given? The deviator stress is given as 80 kilopascal. Confining stress is given as 100 kilopascal, and pore water pressure is given as how much? 50 kilopascal. So minus 50. So if we are solving this, then we are getting 130 kilopascal is your effective major principal stress. Then what about your sigma 3 dash? Sigma 3 dash is nothing but a effective minor stress. That is nothing but a total minor stress minus pore water pressure. That is nothing but a 100 minus pore water pressure 50. That will be equal to 50 kilopascal. That's it. Now we know sigma dash value and also we know the sigma 3 dash value. Now substitute these two values in this equation. Sigma 1 dash, that means we are using 130. That will be equal to minor value, that is nothing but 50 into tan square of 45 plus 5 by 2. Right now, so if you are 130 by 5, 130 by 50, and also take the under root, then how much will get? We'll get the tan 45 plus 5 by 2. And if we are using some calculation, then we will get the 5 value, sorry, 5 dash. We'll get the 5 dash value will become around 26.39 degrees. So if you are using in calcs, so obviously that you will get the values in the decimals. So even in the question also they have represented that, see, in degrees up to 1 decimal point. So even if it is a numerically enter type question, we have to enter the answer in decimal only. But they are asking in up to 1 decimal place. Now see here, if it is 26.39, what is the option we should mention? So we should enter it as like 26.4. Suppose if it comes 26.31, then how much we should enter if it is up to 1 decimal? Then we should enter it as 26.3. So here, depending upon the, like in the given question, they will definitely mention you that either you should enter answer up to 1 decimal or you have to enter up to 2 decimals, 3 decimals. They will clearly mention you in the question. So up to that decimal, we have to report the answer. If you report the answer in lesser than that, suppose even if I'm getting 26.39, blindly if I keep 26 degrees, then again this is wrong. right? So depending upon the given question, we have to report the answer. Suppose if they are asking report the answer up to 3 decimals, then we have to report the answer up to 3 decimals. That is must and should. Why? Because they will give some limits. So if our answer is in that limit, then only they will give us the marks. If we don't see the limits, even though we have done the question correctly, but we may not get the marking. As it is, we have to enter the answer, so no negative marking will be there. So depending upon this value, as they're asking up to 1 decimal, then I will enter the answer as 26.4. So this is what some question based on the triaxial test. So if any question, normally if any question is coming from the triaxial test, so here this is the major equation that we have to follow. Like, I don't say in every problem, but in most of the cases we can say it. And the next important thing from the triaxial, the question from the question of triaxial test is that we should know what is the type of test we are conducting, whether we are conducting consolidated drained or consolidated undrained. Like that, we are having three different types of tests. And also in those three tests, again we are conducting, whether suppose if we are talking about the clay, either we are conducting the experiment on normally consolidated clay, or whether we are conducting experiment on over consolidated clay. So depending upon the type of test and also depend upon the type of the clay, our parameters may change. So if you don't by heart those parameters, then we may not get the correct answer. So it is not only mandatory to remember this equation, but also if it is a triaxial test, we have to understand the types of test and also type of samples and their properties. Then only we can get the marking. Not marks, we can do the questions. Even if we simply by heart this question, see, in this question, if we don't know this is equal to 0, then we cannot obtain any solution. So that is what the heart of the problem. Okay, next, let us see here. A soil sample is subjected to a hydrostatic pressure. The more circle for any point in the soil sample would be. I think this question is like most of you guys have seen this question also related to the strength of the materials. There also you will find out the stress at a point, like normal stress at a point and also shear stress at a point. And in strength of materials, you might have studied about the Mohr circle. Only the difference is that in strength of materials we are applying the stress at a point in a for a solid material, but here we are applying that in a soil sample, but the concept will remain same. So here if it is a soil sample means only the one thing is that they will resist through shear stresses. That is the only one thing. So suppose if you are, let us say that there is a soil sample, and what is meant by hydrostatic pressure, in all directions the pressure it is subjected is same. Let us say you can consider if it is a hydrostatic pressure, it is mean that uh, compressive in nature. So that's why I have represented these stresses towards the point. So what they have to find? More circle. So if you want to draw the more circle, so what we should know? So more circle, that means we are talking more is generated, dependent stress at a point that can be find out by drawing a circle. That is what generated by the more. That's why more circle. So if you want to draw a circle, what are the properties that are needed? We need the center of the Mohr circle, and also we need the radius of the Mohr circle. Let us assume in general, if I am drawing some circle like this, let us assume this is the center of the Mohr circle. From the origin, at what distance your center of circle will be. So if you are representing that, see in general, along the x-axis we will represent the normal stresses, along the y-axis we will represent the shear stresses. So according to the Mohr, the center of a circle from the origin will be at a distance of sigma 1 plus sigma 3 by 2. And the radius of Mohr circle, it is nothing but a sigma 1 minus sigma 3 by 2. And As the soil sample is subjected to the hydrostatic pressure, that means whatever the direction you take, the pressure acting on the soil is same. That means you can say that your sigma 1 that is equal to your sigma 3 that is equal to sigma. Then if you substitute this equation, sigma 1 and sigma 3 are same, then what will be the radius? Radius is coming as equal to 0. Then what about your center? Sigma 1 plus sigma 3 by 2. That means sigma plus sigma by 2. That means nothing but a sigma. So what will be your more circle will like? It don't have any radius. What is meant by it don't have any radius? That means it is nothing but a single point. If it is a single point, that point is at a distance of sigma from the origin. Now see the options. Option A circle of radius sigma and center at origin. Is that it? No. Radius is equal to 0. So first option we can eliminate it. A circle of radius sigma, radius 0. That means this also we can eliminate it. A point at a distance of sigma from origin. That means the third option is satisfying it. So here option C is the correct option. And let us see one more example, that a drained triaxial compression test on a saturated clay yielded the effective shear strength of 15 kilopascal and 5 dash, that means effective angle of internal friction 22 degrees, and consolidated, what is experiment? Consolidated undrained triaxial test. That means here we are conducting the CU test on an identical sample of this clay at a cell pressure of 200 kilopascal developed at a pore water pressure of 150 kilopascal at failure. So let us understand this once again. So what they are saying, a drained triaxial compression test on a saturated clay yielded. That means at first we are conducting the drained test. So if it is completely drained, consolidated and drained, then what they have observed? We have observed that the effective stress parameters, that is nothing but a C dash, that will be equal to 15 kilopascal, and also they have given effective angle of internal friction, that will be equal to 22 degrees. Okay, keep these two aside. And what they're asking now, what they're using, they are conducting the, for the same sample, they are conducting the undrained test. So at first they have done the drained test, and in the second time for the same sample they are conducting the undrained test. Same identical sample, and it is subjected to a cell pressure, and also it is subjected to a pore water pressure of 150 kilopascal. That means they have given shell pressure is nothing but a sigma 1. Sorry, cell pressure is nothing but a sigma 3. They have given us 200 kilopascal, and also they have given pore water pressure that is equal to 150 kilopascal at failure. What they're asking? They're asking us to find the what is the deviator stress, isn't it? Now, suppose, let us say if it is a drained test, so what about the effective cell pressure? That is nothing but a sigma, for the, as we are conducting on the same sample, we can say sigma 3 minus u. U is nothing but pore water pressure. That means 200 minus 150. That will be is equal to 50 kilopascal. Now, let us recall the equations for a drain test. For a drain test, I can write it down that sigma 1 dash, that will be equal to sigma 3 dash into tan square of 45 plus 5 dash by 2 plus 2c dash of tan of 45 plus effective angle of internal friction by 2. And what they have given from the given data, they are given that effective cohesion, that is given as 15 kilopascal, and effective angle of internal friction, they are given as 22 degrees. So only the thing is that as they have mentioned that same identical sample, so as we're using the same identical sample, only the difference is that they both will be subjected to same cell pressure, but in one test we are conducting the drain, on the another time we are conducting the undrained. So if we are conducting the drain, only the simple that we are using the effective stress parameters. If we are conducting the undrained, that means there we are using the total stress parameters. So that is the difference. Okay, but both will be subjected to same magnitude of the stresses. But again, the thing is that their stress, stress parameters, that means cohesion and the angle of internal friction in total drain will be different and in undrained will be different, but they both will be subjected to same amount. So here sigma 1 dash, how can we write it down? That is nothing but a sigma 1 plus sigma 3 minus u. We can write it down, isn't it? Or we can say it is a sigma d. So sigma 1 I can say it as a deviator stress plus confining pressure. That will be equal to sigma 3 dash. We have already find out how much it will be. 50 into tan square of 45, and the effective angle is given as 22 by 2 plus effective cohesion is given as 2 into c dash is nothing but a 15 into tan of 45 plus again 5 dash is given as 22 by 2. And if you are solving this, then we will obtain your value sigma d, that you will get it as around 104.3 kilopascal. So here you should assume that as they're asking the deviator stress, and we should note it down that from these two values we can find out the effective minor principal stress, and then by using these two parameters we can correlate the relation in the form of effective parameters. Then we can obtain the solution, right? Thank you. Next, now let us see a direct shear test. So here they are given the direct shear test is conducted on a cohesionless soil. As it is a cohesionless soil, we already know that or indirectly is given as C will be equal to 0. A specimen under a normal stress of, so let us say the normal stress I am representing with sigma. Sigma will be equal to 200 kilonewtons per meter square. And it is observed that the specimen failed at a shear stress of 100 kilonewton per meter square. That means shear stress at failure, or we can also call it as a shear strength of the particular soil sample. That will be given as how much? 100 kilonewtons per meter square. So I think, hope it is a direct question, isn't it? What they're asking the angle of internal friction. So if it is a direct shear test, what is the relation? S is nothing but a C plus sigma tan phi. So only one thing we have to understand here is that the specimen failed at a shear stress of, wherever they are mentioning that if it is failing at that point, that means up to that point only the soil is having the sufficient capacity to resist the applied forces. So wherever they are mentioning that it is failed at a shear stress of, or at that point we can take it that the shear strength of the soil is nothing but 100 kilonewtons per meter square. That's it. They have directly given all the values, substitute in this equation. So only the thing is that you should understand that this value is nothing but a shear strength of the soil. 100, that will be equal to cohesion, they are already given it as 0, plus sigma value they have given as 200 into tan phi. Then if you have solved this, then we will get your internal friction is around 26.6. It is a simple direct question just based on the direct equation from the direct shear test. Okay. Now let us discuss one more problem. So what is given data? Again, they are given a triaxial shear test. For a triaxial shear test conducted on a sand specimen, see, the test is conducted on a sand specimen at a confining pressure of 100 kilonewton per meter square under drained condition. So this is under drained condition, remember, resulted in a deviator stress at a failure of 100 kilonewtons per meter square. And what they're asking? They're asking the angle of shearing resistance of the soil would be. So what they're asking? So it is a triaxial test and it is conducted on the sand specimen. Did they mention anything about the type of test? No. But you can see here, it is under drained condition. As it is under drained condition means we have to use the effective parameters. So confining pressure, that is nothing but a minor principal stress. As it is under drained condition, we have to use the sigma 3 dash. That will be equal to how much it is given? 100 kilonewtons per meter square. And also they are given deviator stress. Deviator stress sigma d dash, that will be equal to, again that is given as 100 kilonewtons per meter square. And you can ask me that resulted in deviator stress at a failure of, here they didn't mention anything, isn't it? But there is only one possibility, that that should also be a drained condition. So sigma d is also nothing but a 100 kilonewtons per meter square. So what do we have to find it? We have to find out the phi. As the entire experiment is under drained condition, that means whatever the shearing resistance you are finding, angle of shearing resistance, that also will be in terms of the effective angle of shearing resistance. And as we are talking about the sandy soil, the experiment is conducted on a sandy soil. As the experiment is conducted on a sandy sample, what about the cohesion? Cohesion for the cohesionless soil will be equal to 0. So again recall the equation. If I recall the equation, sigma 1 dash, that will be equal to sigma 3 dash into tan square of 45 plus 5 dash by 2 plus 2c dash into tan of 45 plus 5 dash by 2. As again, the experiment is conducted on a sandy soil, your c dash will be equal to 0. That means again this entire magnitude will be equal to 0. Then what about the sigma dash? That is nothing but a summation of the deviator stress plus the minor principal stress. Now, if I substitute in that equation 100 plus 100, 200, directly I am writing here 200, that will be equal to 100 into tan square of 45 plus 5 dash by 2. Then if you done the simple calculation part, then you will get your effective friction angle, that is nothing but a 19.5 degrees. So that is nearer to the option B. So if it is a triaxial test, as we have already discussed, the main heart of the problem is based on this equation only. And again, as I'm saying, depending upon the type of the soil we are conducting the experiment, and also depending upon the type of the test, we have to understand the uh, like behavior of the soils and their parameters variation. Only means where the parameters will be equal to 0, then only we can obtain the solution. Again, this is also direct question based on the triaxial test. Okay, now let us see one more question. So what is given data? The stress path equation for a triaxial test upon application of deviator stress is. So see, here they have directly given the relationship between Q and P. So what is the relation? Q, that is given as 10 root 3 plus 0.5 P. So this is what the variation of the stress path parameters, P and Q variation. And what they're asking? They're asking us to find out what is the value of C, and also we have to find out what is the value of phi. So this is very, very important question, or we can say it is a difficulty level also. So we should understand first. Imagine by seeing these two. First, let me draw the stress path curve variation along the x-axis and along the y-axis. So along the x-axis, I should consider the parameter P. Along the y-axis, I am considering the parameter Q. And these two, how they are varying, they are giving the some variation. So what is the variation? It is in the form of 10 root 3 plus 0.5 P. Suppose let us say that if your P is equal to 0, that means at this point, if your P is equal to 0, what is the Q value? That is nothing but a, the value is nothing but a 10 root 3. That means at the origin, it is having a Q value of 10 root 3. And how the curve is varying, and P and Q, how they are varying, see this equation. So This is a constant. And how they are related? Q and P, they are related, or you can see the power. Q and P both are having the power 1. If both are having the power 1, then what we should say? We should say that they are varying linearly. So as they are varying linearly, then what should you say? Then imagine I will draw some inclined line. So this is what nothing but your stress path variation. Okay. As of now, okay, we have got this value. So let us assume that this value is nothing but some xi. Okay. Now, what we have to find? We have to obtain the for a soil sample. What is the cohesion value, and also we should obtain what is the angle of internal friction. So if you want to obtain this, first you should understand the sum of the relations. So if you don't remember these relations, then it doesn't mean that we can't solve it, but the problem length here will be higher. But if we understand these relations, then we can obtain the solutions easily, right? So first I will write down the relations, and if you don't remember these relations, we should follow this specific way. I'll explain you that later on. So that relation I can say that sine phi. Here phi is nothing but internal friction. That can be written as nothing but a tan psi. So if you can find out the tan psi value, then that is also nothing but a sine phi. And then based on that relation, we can find out the phi value. And second relation is that, let's suppose let us say that, let us say this distance is nothing but a some value. Let us say this is some value z. Let us say this is a value some z. And now we can say that the cohesion that can be represented as nothing but a z divided by cos phi. So if we can remember these two values, then we can obtain the internal friction, and also we can obtain the cohesion values. Imagine that, suppose if the curve is started here, imagine if the curve is started here, then what about the z value? Z value will be equal to 0, isn't it? So if your z value equal to 0, then what about the cohesion? 0. So like if you are drawing the stress variation, like along the normal stress and the shear stress. Even if I draw a curve like this, then what does it mean? Your cohesion is equal to 0. So even the variation of tau and sigma, or even if you are drawing the stress path variation, if the curve is starting from the origin, then without doing any calculation, we can pick up that your cohesion is equal to 0. But here there is some y ordinate. So definitely you are having z value. Z is how much from the given question it is given as z will be equal to 10 root 3. And if we want to know cohesion, then obviously we should know phi value. So if you want to know angle of internal friction, then we should understand what is the value of tan phi. So how can I find out the tan psi? Tan psi is nothing but a what? It is nothing but a slope of this curve. So what is the equation, or how the curve is changing? The curve is changing in the form of 10 root 3 plus 0.5p. Then how can I obtain the slope of this? So just think about it. How can I obtain the slope? If I partial differentiate, or if I differentiate this function with respect to the p, then that is what nothing but my slope. So I am having the function q. It is nothing but a 10 root 3 plus 0.5p. I need the what I need? I need the tan xi. That means I need the xi value. That means if I need the slope, I should differentiate it. If I differentiate it, what I can write? dq by dp. What can I write it down? So this dq by dp, this, if you remember this, I can write it down a tan xi also. That will be equal to, what is the differentiation here? As it is a constant, 0, plus what is the differentiation with respect to p? 1. So 0 plus 0.5. So what about the tan psi value we have obtained? It is nothing but a 0.5. As we have already discussed, tan psi, that will be also equal to the sine phi. So sine phi is equal to 0.5. So sine phi equal to 0.5. Then what about the value of phi value? If phi is equal to 30 degrees, then Your sine 30 is nothing but a 0.5. See the small relation. Only the thing you should know that if you differentiate with respect to the function p, then we are getting the slope of the stress path, and that slope, it is nothing but a tan psi. If you don't know that, how can you apply this? Then we can be in a trouble. Otherwise, even if you, even your mind it didn't strike that we have to differentiate it, then still we can do the problem. How? As it is a linear line, then we can say that the slope is constant at any point, isn't it? Suppose let us assume that at the origin, what about your q value 0, and arbitrarily take that your p is equal to 1. Let us assume at p equal to 1, what about your q value? Your q value will obtain it as 10 root 3 plus 0.5. So already here 10 root 3 is there. So what about this here? 0.5. And what about your p value? 1. So from this, use the tan phi. Tan xi. Tan xi is nothing but a opposite is nothing but a 0.5 divided by 1. So why, you can ask me why I can take only 1? You can take it 2 also. Suppose if I take it 2, p equal to 2. 10 root 3 plus zero point 0.5 into 2, 1. So here it is 0.1. Sorry. Yeah. zero point 0.5 into 2, 1 simply. And p value I taken 2. That means from here to here, what is the value? 2. So tan psi, that will be equal to 1 by 2. 1 by 2 is also nothing but a zero point 0.5. So either you can use the differentiation part, or else by seeing this diagram itself, we can find out the psi value. So it is always not mandatory that we should recall all our mathematical knowledge and all. But sometimes if we use our common sense, that means even if don't strike that we have to do the differentiation part, still if we can understand the basic mathematics, then you can get the slope of this point. So we already got phi value. So from the phi value, so what about the relation for cohesion? Cohesion relation is nothing but a z divided by cos phi. So z value is given as how much in the given question? 10 root 3 divided by cos 30. So cos 30 is nothing but a root 3 by 2. Root 3 get cancelled. If 2 goes to the new upward, then what about you're getting? Your c value will get it as a 20. Correct? Did they mention anything about the unit here? Right? Nothing. But they are mentioned it is a kilopascal. Okay, fine. How much you're getting cohesion? 20. And how much your angle? 30 degrees. See? And also one more thing. While picking the answer, see, 20, 20, 30, 20. See, the main major mistake we can do here also. We got the answer at 20, 30. But okay, if we think in a reverse manner, that means if we take 5 value in 30, C value 20. Okay, here we can say that okay, degree is there. Okay, well, how can we pick up it? But in the examination hall, due to this hurriness and due to the tension, sometimes we may pick up this answer also. That means even though you know the correct option, you know the solution, but still in a hurriness, you can pick up this option also. So first thing is that doing solution is important, and after completing the solution, we have to pick up the we have to select the correct option. You know the correct solution and you didn't pick up the correct solution, then again we'll get some negative marking. So you should know, you should be very careful while doing the solution, and also you should be more careful while selecting the option. Why? Because in a hurriness, if you select this option D, then it's gone, right? So doing solution is also important, and also selecting the option is also a very very important thing. Okay, so like that, the okay, it is understood that everyone will have the tension and the examination and all, but if we can decrease that, how we can decrease it? By practicing so many problems we can decrease it. And if we get some confidence, then in exam we can attempt in an effective manner, that means without doing any silly mistakes. Okay, these are the some of the previous year gate questions on the laboratory test for determining the shear strength of the soil. Okay, for more detailed lecture, go join Ekeeda and go through the lectures. Thank you.